Hi, welcome to the Buenaventura IEEE Computer Society May meeting. I'm Don Thomas, the chair of the Computer Society here for the IEEE Ventura chapter. And today we have a great presentation using embedded graphics for AI robotics. I'd like to introduce Samir Ronnie Dhillon, who will be presenting on NVIDIA graphics AI and embedded systems for robotics. Samir, thank you for presenting, and I'll hand the controls over to you. Samir?
Thanks for introducing me, Don. So I'll take it over from here. I don't know if you can see my video, but let's see. All right, so my name is Samir Dhillon. My middle name is Ronnie. I'm a senior technical manager here at NVIDIA. I run the AI research lab for demos, and I'm an NVIDIA master inventor. I typically talk about all of our domains. I'll try to keep it narrow and focused on embedded computing and robotics at the edge and try to show off some of those use cases. So the first one we're going to talk about, we are a gaming company as from our history. So here's some introduction to the latest RTX gaming and some tidbits into how we're changing it and revolutionizing it with AI.
Welcome to our world, where every click, every moment, and every detail matters. From creating new worlds to epic solo adventures and chaotic multiplayer showdowns, we take you beyond the edge. And by uniting fearless innovation with the power of AI, you're charged with superpowers, making every move momentous and bringing every concept to life. RTX, it's on.
That is an example of what we do in terms of gaming and how we use AI to revolutionize gaming. These are some of the basic segments that NVIDIA offers today, from data center computing to our gaming platform and graphics platform called Omniverse, digital avatars, and robotics and self-driving cars. I'll be talking a little bit about each one of them all throughout our evening today and our 1 hour session today. So to start off with, let's start with Omniverse. In front of you, you're looking at an example of what we call an RTX ray trace simulation. Internally, this asset's called Ramen Shop. Everything that you're watching here is not a real ramen shop or is not photographs, but is a simulation of a ramen shop inside of Omniverse. So you can see the level of detail and fidelity that we offer using our graphics platform for digital twins and simulations. But to kind of show you some of the other examples, this is what we call Racer X that we built internally to kind of show off the capabilities. We do some dominoes, other effects, and other types of simulations for somebody's personal bedroom. We've done all different types of asset projects inside of Omniverse as a showcase. So this is an example of a loft, is what we call it internally, with different lighting conditions. We also have simulated our buildings. So this is the NVIDIA headquarters that has been leveraged to be simulated originally in some of the aspects in iRay, V-Ray, and Unreal Engine, and eventually moved into NVIDIA Omniverse when we have the platform available to us. Everything that you're watching in this new montage is actually in Omniverse as a simulation piece. Everything is running in real time on 4 to 8 GPUs simultaneously. So here you can kind of see all the different things that were built in Omniverse, and then usually people again go, what is Omniverse? I really did not get it. So Omniverse is an open USD true to simulation to reality platform that enables you to collaborate with multiple users and enable AI on top. Here you can kind of see a simple slide that explains how you have different three examples of 3D objects, textures, materials, and the environment interacting simultaneously, alongside with animation, geometry, and AI path tracing and physics, enabling it together. So this is an example of Omniverse. Here are three users on the left in their own individual applications, building a kitchen scene, working on their own individual artist supremacy. So here on the left, you can see on the bottom right is an artist that's working on Maya. On the bottom, in the middle is an artist working on Substance Painter. On the top, somebody's working on Unreal Engine. All three of the users are now collaborating together into a unified scene, or what we call a digital twin, inside of Omniverse on the right. And that is the power of Omniverse, where people usually think we're trying to replace the existing tooling or platforms. That's not our goal. Our goal is to be a collaborative platform that can help you visualize digital twins dynamically for industrial digitalization with AI. So to start off with, this is the BMW factory. This is their Regensburg plant. As a showcase, the cars are in false color to protect their paint IP. Everything else is in true color to show you the full end-to-end representation of their whole factory. The cool thing is you can actually walk down all the aisles. We use NPCs to simulate how many steps does each employee take throughout the day, understand those dynamics, and then simulate all of those in our simulation platform to understand how the layout of the factory can either help you drastically reduce the amount of steps or reduce the amount of injury that might be a chance of injury caused to the employee. We also have unique things where we can actually take some of the large-scale robots, like these 3D painting robots that actually takes a car, dunks it into a tank or a vat of paint for the first layer of coat rather than spray painting it. There are a few things that you can only do in simulation, like you can actually take a car, like in this case, this is the BMW X5 SUV assembly line. So I can just press a couple of keystrokes and then make the BMW engine explode inside of Omniverse as a showcase with every screw and bolt. And of course, you can step into it with VR, so you can actually go into the physical space and then experience it firsthand with a VR headset or an AR headset. This is how we use NPCs to calculate the amount of steps, train things on slip and falls, deep knee bends, typically things that you do not want real human beings to do. We use these digital characters to do those tasks and train AI on those digital characters for body pose and other types of estimations on synthetic data. We also do this at city level scale. So this is an example of Kista, Stockholm that we showcased from generating from satellite imagery and cesium tiles. You can now simulate city level scale in Omniverse in just a couple of weeks. On the left is the digital twin. On the left is the real life example. On the right is the Omniverse digital twin. Here's a side by side as an example of how close we can get simulation. The goal here was to understand 5G base station planning so that you can understand where do we put the 5G base stations, how does the coverage map affect, simulate all of the beamforming and line of sight virtually as a showcase before deploying it in real life on that particular building. This can of course be done for Wi-Fi also, so it doesn't have to be limited to 5G and 6G technologies. We also can check for Wi-Fi coverage maps inside of stadiums and other locations. Finally, coming on to our most dynamic digital twin, we call this the Amazon warehouse. This particular one, Fremont, rearranges itself every night based on what customers search on the website. So based on, let's say, an Instagram influencer did a viral campaign on hula hoops, Amazon will take one of these robots and move all the hula hoops to the front, offering Prime 1 day for some of the users to have a higher sales conversion than a standard retailer. All of the rearrangement of the warehouse is done in the digital twin first to make sure nothing collides or crashes with each other. An engineer goes over the validation and production of all of this inside of the Omniverse simulation, like you can see here. to validate to make sure all of it fits, and then it gets its final approval, and the robots autonomously then move around the whole warehouse. It is a bi-directional connector, so anything that you change in Omniverse then changes in your Autodesk, Revit, or other types of tool engines that you're using. Like in this case, we're changing an air conditioning duct that should be changed in the architectural drawings on where it's actually moved to kind of keep the building digital twin updated. Finally, coming to our biggest digital twin of them all. So we at NVIDIA took on the initiative with 172 engineers spread out across 4 continents to help them build out a digital twin of the whole planet. We're doing this to essentially accelerate the understanding of climate change and leverage techniques and use cases to mitigate them in advance. We're looking into using FNO predictors or Fourier neural operators to talk about showcasing atmospheric rivers for things like affecting San Diego or things on our west coast like we have in our rainy season. We were able to leverage our FNO predictors for older use cases like Hurricane Dorian, show the amount of devastation caused with AI, do a before and after, without ever having to send a field agent out to remote areas like Bahamas or other areas that are hard to access as remote islands. On the right, you can see orange is our prediction, blue is ground truth. You can see how well ground truth correlates to our digital twin experience for simulation. Finally, this is one of our most advanced chips in full production today. It's called the NVIDIA H100. It has a transformer engine and has our multi-instance GPU or MIG technologies to actually run individual isolations, up to 7 different instances of different use cases that you might want to render for multimodal AI also. We offer it in multiple form factors, whether it could come in a PCIe card or an SXM form factor for the DGX use cases. We leverage them in our buildings for multiple use cases and even for smart cities. Here are some of those examples, like on the top left, you can see we're counting people, pedestrians, and other examples. On the top right, we're identifying the car, unique IDs. Bottom left, we're identifying license plates, other examples. And on the bottom right, we're identifying gestures and other showcase examples for it. We use collaborations from KFC and McDonald's, where pretty soon they're going to leverage some of these technologies to understand if you cannot make up your mind on what to get on a McDonald's or KFC drive-through, they can look into recommendation features like what have you been there in the past, what kind of car do you drive, and other examples like that to recommend you a meal based on their price sensitive and other types of geographical information that they might have. Finally, we do this for semantic understanding. So on the top, you can see left is the video that's being fed into the AI. On the right is all the labels that is automatically labeling for the video that's being fed to it with what we call essentially edge censored information. So we're not tracking anybody's faces. You can see all the faces are redacted and blurred. All the license plates for those individual cars are redacted and blurred as a use case too. You can, of course, do this for body pose. So on the bottom left, you can kind of see us having one of our employees on the moon, as an example, controlling one of the moon rigs as a use case as an astronaut from Earth. And of course, you can use it to control digital avatars, or we'll call it make you dance, where you can actually make yourself dance, even though you might not be capable of doing that physical dance yourself. In the middle, you can see our pose detectors in 3D that can not only do pose detection, but also give you estimations of different types of zero-shot models for what the pose is doing, whether it's walking, standing, sitting down. And on the right, extreme right, you're seeing us using it for robotic simulation for understanding and training a robot with imitation learning rather than reinforcement learning. Finally, we do all of this for different use cases, not only human beings. I'm personally getting a patent on facial recognition for bees. We do this for cows, chickens, and other types of use cases for animal husbandry, not just human beings. So pick and choose different examples that you would want. Pick and choose different examples that you would want to showcase for different use cases. Like for the late night TV shows, we mentioned the Fat Bear competition, where we essentially kind of calculate the weight of the bear by using computer vision. We of course do this for all different types of human beings, and we power the world's smart cities. So if you have a smart city in your location or in your county, we actually are probably the technology powering it indirectly or directly. Here are some of the use cases, and some of the partner names are listed on the bottom who are using our technology to support some of these initiatives across. So to kind of close, this is our embedded platform. So everything that I showed you before are some of our top of the line GPUs. This is our lesser known chips called the Jetsons, kind of named cutely after the cartoon. These are the edge devices or IoT or embedded devices. You can find them in your different types of appliances. If you're building an IoT application, I recommend getting one of these for your AI applications. If you're building a self-driving car, I recommend one of these. Or if you're building an autonomous robot, I recommend one of these. To show you what it can do, let's start off with what we call Gaussian splats or neural radiance fields. This is a video from my phone that has been now stitched into a 3D model in an Omniverse using some of our AI technology. So this is what we call 2D to 3D or NERF or Gaussian splats in general. But now you have a full-scale 3D model from just a 2D video available to you that you can interact with from just your phone. You don't need high-end GoPro cameras, high-end Nikon cameras, or professional rigs to do this with the help of AI. You can now do this with just your standard phone cameras. We, of course, use this in pretty aggressively in self-driving cars. So everything that you're watching on the screen is a real self-driving car driving down the street now. You can kind of see an example with the real cars, real license plates. Everything that you're seeing now is actually an Omniverse viewport. This is not reality anymore, or this is what we call simulation or the digital twin of that street. The cool thing is everything is 3D, so you can actually capture things in 3D too. So typically tow trucks and ambulances are really hard to find in real life. You have to chase one down. So you can now collect the tow truck and ambulance in 3D and then use them for whenever you want to with large language model prompts. So here you can kind of see with an LLM, we can just type in, put in a kid, put in a ball, put in the tow truck and some cars, and to see if my car actually brakes on time for that kid running by chasing the ball in front in simulation. So you're only limited by the amount of scenarios that you can imagine and think of. We typically try to simulate all the auto insurance claims made in that particular area, or the particular scenarios that we can typically imagine in those situations, and force our cars to understand a larger dynamic world environment. Another example here is the real downtown San Jose, now transitioning into virtual San Jose or simulation of San Jose in DriveSim. So you can see how we helped some of our self-driving car companies and partners like Tesla, Mercedes, and others build self-driving cars as platforms. Tesla typically tends to use us in the data centers, where Mercedes offers us in-car solutions using our technology. What most people don't realize, a self-driving car is a robot. So technically your biggest robot, there will be all different sorts of robots and platforms. So here are some of our partners that we power with NVIDIA Drive all across the platform for multiple car companies. And we, of course, do the same thing for Drive Autonomy. This is a real example where
Hi, Pavithra. You have an event at Plaza de Cesar Chavez Park at 6 p.m. Would you like me to navigate there?
Yes, please.
Beginning Drive Pilot.
One way to tell that this is all real is you can tell how nervous Pavitra will be sitting in the actual car or driving itself completely autonomously without any human beings paying attention to it, because in real life you can find people on their cell phones and across not looking at a car, and you can see how well our car handles some of those dynamic situations.
You have arrived.
And of course, your self-driving car being your most personal and biggest robots, these are all the different types of robots that we support in our ecosystem. You can kind of see some of the examples here with our robots that are humanoids, autonomous machines, and other types of use cases like even flying cars. Here you can kind of see how we train some of these robots. This is using one of our LLMs, creating a digital warehouse so that the robot can learn autonomous navigation in that warehouse inside of Omniverse. So here you can see our Carter robot learns how to navigate alongside with some forklifts and other use cases inside of a virtual world to understand the dynamics of those virtual worlds to work itself in the real world. These are some of the other robots and some of the other use cases and platforms that we have. So this is our pallet picker called Oblix. It can move a pallet around independently, kind of like Amazon's pallet picker. We also have our animal robot and our Festo robot that can pick a place and do different tasks. All of them are simulated end-to-end inside of Omniverse and then correlated to reality to kind of do sim to real. And you can kind of see how we train them at large-scale simulations for warehouses and other use cases. This is our pick-and-place robot called Festo. You can kind of see the digital twin on the right and the physical model on the left. My personal favorite is called the Animal. It is this quadruped that actually learns how to walk around in our simulation space and then can actually do it in real life, as an example. So I'll finally close with this last example that shows off all the different robots that we have in our platform. We have close to about 250 different platforms for robotics. Everything that you're watching on a screen is powered by a Jetson platform, one of our Ed chips. With that, I'll move to some questions. If you have any questions, queries, concerns, feel free to ask and fire my way.
Well, thank you. So everybody on the call, you should be able to either unmute or type something in the chat window. Either way should work fine. Personally, I'm just blown away by everything I've seen tonight.
Oh, that was fantastic. Yeah. In fact, I was just seeing a small GPU set now for a Raspberry Pi. You can actually use it for AI. That sort of was new to me in the last couple of weeks. But yeah, any questions on the floor?
Yep, so the Jetson's roughly about 200 times faster than the Raspberry Pi. That's why I usually don't compare it to that one. I would rather compare it to the Apple M2 or the laptop series. So, because some of them are pricey. Yeah, the Raspberry Pi is very cheap.
Yeah. Very good.
All right. Sana, I see your hand up, but I don't see a question. You should be able to unmute or type it in the chat, either way. Yeah, really, the high end stuff you show here is like I say, I usually have a question for a speaker, but I'm kind of so blown away by this that I really don't can't think of anything. It is pretty amazing the stuff we're going to be seeing.
Yeah.
We're already seeing and will be seeing in the next year or two.
Yeah, it's pretty overwhelming. Let me ask you this, Samir. What type of talent are you looking or seeing in the future to help with the AI job market?
So I personally don't give job recommendations because what if I told you every job that you can think about will be obsolete and automated, including mine? So I am a programmer for a living, so it's not like the AI is not going to come after my job. It's going to come after my job equally the same way it's going to come after every other job. So what we should look towards as human beings in general towards higher hierarchy of jobs. So we typically look at now what we call domain knowledge experts at NVIDIA. So if you typically would want to learn a domain better than what a machine or a general AI agent can present it to you. And the more generalized these AI tools get, the more better of a domain expert you would have to be. Long term, the domains, you can pick and choose your domain. It could be something as simple as gaming. That was my early on domain, which evolved into AI and other types of machine learning models. But it could be something as agriculture and all of that. And AI will be one domain that will affect every space in some form or another.
All right. Sana, if you're able to unmute, go for it. You're next.
All right. Hi, everyone. Thank you so much for the presentation, Samir. That was very, very inspiring. And I can't wait to try it. What's your recommendation for someone who might just want to start tinkering with a specific kind of simulation in the Omniverse? Do we need to have a GPU? Is there a cloud platform we could use to get started? What is kind of a way to get your hands dirty with this technology?
So for AI, it's pretty easy. Just go to ai.nvidia.com. You can get something running there pretty quickly. You can get Llama 3 or some of the newer chatbot models like Minstrel or some of those running locally on our cloud compute. For Omniverse, the question's a little more complicated because if you are somebody that's an individual or creator, the license is free. If you have a Windows computer, you can download it and make it available. But if you are a big gaming studio or a virtual production studio, the license, there is a software license attached alongside with the hardware license. To run Omniverse, you typically do need a GPU, so make sure your laptop does have any kind of GPU that could run an NVIDIA GPU specifically to run Omniverse.
Okay, and most, I think, like, let's say I have a run-of-the-mill Intel Core i7 laptop from the last 4 or 5 years would be able to run something like the Omniverse on it. With a
As
GPU.
long as it has an NVIDIA GPU with an RTX symbol. So we stopped making RTX GPUs. Sorry, we started making RTX GPUs in 2015. So if your laptop is older than 2015, it probably cannot run Omniverse.
And do we have, what kind of programming language know-how would you need to start using that?
Omniverse is a GUI-based tool, so you don't need to know programming. If you know Python, you can code in Python if you wanted to.
Perfect. Thank you so much.
All right. Any other questions?
Quick question, is there like anything in a GUI base, like open source or something, or some special software do we need to use?
Sorry, what was the question regarding like spatial software for?
Yeah, I'm saying, is there like any open source or some tool for the GUI based software, or there is like specific like
The
GUI?
open source software is called Omniverse.
Okay. Thanks.
Anyone else? Going
Okay.
once? Go ahead, John.
Yeah, okay, with that, no, I was just going to close it out, Darren, unless you had a question.
Nope, I did not.
Well, thank you so much, Samir, for presenting. It was mind-blowing, to say the least, what we've come to. But thank you again, and I really appreciate it. And hopefully we'll be talking to you in the future.
Sounds good. Yep. Thank you for having and taking the time.
All right, thank you very much.
Thank you.
And
Bye, everyone.
we'll catch you at the next meeting. Thank you. Bye.
Thanks.